Hello everyone and welcome to another video with Special Maths Academy. In this video, we'll be looking at the 11th problem from the Special Maths Contest 2024, the first round. And it says, on two opposite sides of a unit square, so pay attention to unit square, side length of 1, an equilateral triangle of same length, so same side length as unit square, is constructed in the interior of the square. So what is the area of the region common to both triangles? So first of all, let's sketch this and see what it looks like. So let's say this is a square. And then on opposite sides of the square, we construct equilateral triangles. So we want to see, first of all, that the triangles intersect, and then I want to find the area, this area, okay? So the first thing that you will notice is that that shaded region is going to be a rhombus and a kite. So what I mean by what I mean by a kite is that adjacent sides are equal. So basically, the shaded region should look something like this. The adjacent sides are equal and all sides are also equal. So it's a rhombus and it's a kite. And so now to calculate the area of this shaded region, what one thing we can do is to, break this shape into two. So if we like draw the line like this diagonal, and if we can find the length of this diagonal, that will help us go a long way to getting this area. Why? Because we know that this is an equilateral triangle, so this is 60 degrees, 60 degrees, and the tip 60 degrees, so 60 degrees, 60 degrees. And we also know that since this is a rhombus kite, we know that this tip here is going to be 60 degrees. So in fact, this diagonal, which I've drawn here, is going to be equal in length to the sides of the rhombus. Okay. So basically, if we can get the side lengths of that diagonal, we'll be done. So how can we get it? We can do a little bit of trick. So this is side length of 1. Now we know that since this is a square, this is going to be 30 degrees. So the side length of 1. This is 30 degrees. And this angle here is 120 degrees. Okay. Now, if we can get the height of this triangle, so note that that triangle, the 30, 120, 30 triangle is also congruent to this one here. So this 30 degrees, this 30 degrees, side length 120 degrees. So these two triangles are congruent. Okay, so if we can find the height of this triangle, so the height from the vertex where the 120 degrees is, then that will help us, to find the length of this diagonal. Okay, so basically we can find this length. Okay, so how can we go about this? We can do a bit of trick here. So let's cut out the diagram. Okay, so basically if you draw a line to the midpoint, so this is going to be half. So we have something like this when I bring the diagram out to work on it. So this 30 degrees. And 120 degrees divided by 2, this is going to be 60 degrees. Okay. So now we need to find the length of the height here. Okay. So how can we do? So let's say we call this x. Okay. So we know that in this triangle, sine 30 degrees is equals to what? X over, okay, no, it's better to work with tan 30 degrees. So tan 30 degrees is equals to opposite of adjacent. So x divided by half. Okay. And we know tan 30 degrees is what? 1 over root 3. Okay. So equals to 2x, because x divided by half is just 2x. So we know that x is equals to what? 1 over 2 root 3. Okay. So we know that the gap from here to here and from this tip to this point is, so this is 1 over 2 root 3 or 1 over 2 root 3. Okay. So we want to find this remainder here. So to find it, we can just add these two and then subtract from 1. So basically the length, this length here, let's say we call it h. So we know that h plus 1 over 2 root 3 plus 1 over 2 root 3 equals to 1. Okay, so 1 over 2 root 3 plus 1 over 2 root 3 is just 1 over root 3. And this simplifies to h plus 1 over root 3 equals to 1. And then we have h equals to 1 minus 1 over root 3. Okay, so basically this question mark here, we have this. Now we can break that area to finding the area of two equilateral triangles. So we know this formula for finding area of triangles, that is half AB sine C. Okay, so in this case, because it's two equilateral triangles, it's going to be what? So we can remove the half. So this 2 times half. So since the side lengths are equal, equilateral triangle, we already know the side length to be h. Okay, so 1 minus 1 over root 3 squared sine 60 degrees. Okay, so this simplifies to, so 1 minus root 3, we can, simplify this, is going to be root 3 minus 1 over root 3, okay, squared. And then sine 60 degrees is root 3 over 2. Okay, so we can simplify this further. So root 3 minus 1 squared, that is going to be, so let me just demarcate here. So root 3 minus 1 squared is 3 minus 2 root 3 plus 1. Okay. Root 3 squared is 3. Okay. And we have times root 3 over 2. Okay. And then we can, try and simplify this further. So 3 plus 1 is 4. So we have 4 minus 2 root 3 all over 3 times root 3 over 2. So these two can, divide 4 and minus 2 to give. Okay, so let me scroll down a bit, or I can actually just erase this diagram here to continue. Okay, so now we're just doing some algebraic simplification. So this simplifies to 2 minus root 3 all over 3, times root 3. Okay, and this simplifies to 2 root 3 minus 3 all over 3. So this is the area of the shaded region. And we can check the options, and we can see that it's option A. Okay, so yeah, this was an interesting problem, and I hope you enjoyed it. Don't forget to share, like, comment, subscribe, and see you in the next video. Goodbye, everyone.